Yo, if you're just starting your journey to become a software engineer, you're entering at the best time in history. Not too long ago, learning programming was a very difficult experience. You had to rely on heavy textbooks, endless documentation, try and errors, coding that often left you stuck for weeks. It was slow, frustrating, and sometimes discouraging. But today, things have changed. Learning to code has been more accessible. You have interactive platforms, massive online communities, and the guy in the room, AI. AI tools that guide you every step of the day. AI has turned what used to take days of confusion into minutes of clarity. And you can ask questions, debug codes, and even learn concepts in plain English. That doesn't mean that the journey is effortless. You still need to discipline yourself, practice and increase your problem solving skills. But the path now is clearer, faster, and more exciting than ever before. So, if I had to learn programming all over again, here is the exact roadmap I'll follow, and the same one you can use to kickstart your career as a software engineer. Now, if I was to start learning programming today, the first big milestone I'll focus on is understanding data structures and algorithms. Here's why. Being a software engineer isn't just about writing code that works, it's about writing code that works efficiently. And that efficiency comes from knowing how to organize data and how to process it. That's exactly what data structures and algorithms is all about. Now, let's kickstart with the basics. Arrays. Think of them as shelves in a row. You can quickly grab an item if you know the exact position, but adding or removing items in the middle can be pain in the ass. And up next, linked list. Imagine a treasure hunt where each clue points to the next, which is meh. They are great for adding and removing items easily, but finding something in the middle can take some time because you have to follow the chain. Stacks and queue. These are all about order. A stack works like a pile of plates, last in, first out, and a queue is like a line at the grocery store, first in, first out. They sound simple, but they are behind the scene of undo futures, printers, and tax scheduling. Trust me. Then comes hash tables. This is where things get powerful. Instead of searching through a list, a hash table uses a key to jump straight to the value. It's like having a super organized filing cabinet where you know exactly where every document is stored. Hash tables power databases, caches, and even dictionaries in programming languages. Trust me. Now for tree and graphs. A tree is like a family hierarchy, one root, many branches and leaves. Trees power things like file system, databases, and even how AI makes decisions. For graph takes it a little bit further. They represent relationship, like how your friends are connected on social media or how maps calculate the shortest path from one city to another. And of course, you can't talk about algorithms without sorting. Bubble sort, merge sort, quick sort. The names don't matter as much as the idea. Sorting is everywhere, from organizing your contact to displaying search results. Learning different methods will teach you how to think or about trade-off between speed and memory. Now, here is a key thing. Don't try to master all of this at once. Instead, understand the intuition behind each structure, learn why we use them, not how. Build small projects, maybe a to-do app using a queue, or a contact book using a hash table. That's how it sticks. If you can build a solid foundation in data structures and algorithms, you not only write better code, you think like a software engineer, and that's exactly what companies are looking for. Once you have built a foundation with data structures and algorithms, the next step I'll recommend is learning a mid-level programming language like C. Now, you might be thinking, why C when there are so many modern languages like Python, JavaScript, or Go? Yeah, the answer is simple. C teaches you the core of programming and how it really works. Now, C, high-level programming language often protects you from details, they handle memory, they hide complexity, and they give you shortcuts. Now, that's great for building apps quickly, but if you want to be strong or if you want to be a strong software engineer, you need to know what's happening underneath. C forces you to think about things like, how data is stored in memory. You will learn about bytes, addresses, and pointers. This is like pulling back to curtains and finally seeing how variables, arrays, and strings actually live inside the computer. How data is being manipulated. When you write code in C, you are not just calling built-in functions. You are learning how those functions themselves are built. You are closer to the metal, and that gives you a deeper respect for performance and efficiency. The foundation of every language, almost every modern programming language borrows concepts from C. That's what you should note. And things like loops, condition, functions, even syntax, conversions, traces back to it. Once you understand C, learning new languages become much easier because you can see the common patterns. Here's an example. When you learn arrays in C, you realize that an array is literally a block of memory, and when you go beyond its size, you risk writing into someone else's memory. And that's not just a bug, it is how computer viruses and exploits work. So understanding that changes the way you think about safe coding. Or take pointers, for example. At first, they might seem confusing, but once you get them, you understand how programs passes around data, how references work in other languages, and even how operating system manage resources. Now, don't get me wrong here. You don't need to spend years coding only in C. The goal isn't to become a C developer. Unless you want to, the goal is to use it as a training ground. By learning C, you sharpen your ability to think like a computer, to understand what's really happening when you write a piece of code, no matter the language. That knowledge is what separates someone who just writes code from someone who engineers solutions. So after you have built your foundation with data structures, algorithms, and learned the core concept with C, the next step is to choose a niche. Now, this is where your journey gets personal. Programming is a massive world, and not every software engineer does the same thing. Choosing a niche helps you focus your learning and build projects that align with the kind of career you want. Now, let's go through some of the most common paths. First, we have the front-end development. If you love creating beautiful interfaces and care about what users see and interact with, this is your lane. Now, to start with, we will have what we call the HTML, which is hypertext markup language, and we have CSS and we have JavaScript. Then you can move into frameworks like React, Angular, or Vue.js. And front-end developers bring design to life and make application interactive and user-friendly. Second, we have back-end development. If you are more interested in logic, data, and how things work behind the scenes, back-end might be for you. You see, you learn to build APIs that power apps and handle data. Popular opinions include Java with Spring Boot, we have Node.js with Express, or Go with Golang. Backend developers are the problem solvers who make sure everything runs smoothly and securely. If you want to do both front end and back end, you can go full stack. Here you will understand the entire picture from the user interface to the server. It's more challenging but also highly rewarding, and in startups especially, full stack skills are gold. So the fourth is mobile development. That's if you are fascinated by apps on your phone, mobile might be your thing. Anyways, for Android, you use Java or Kotlin, and for iOS, we have Swift with Swift UI, or you can use Objective-C. And if you want to build for both Android and iOS at once, you can use cross-platform tools like Flutter, and the programming language is Dart, or React Native. We have Ionic, and their programming language are like JavaScript. So yeah, so that's it. Now, If you're passionate about games, you want to explore C++, with Unreal Engine, or C Sharp with Unity. These are all game engines, and their programming languages are C and C Sharp respectively. Now, this niche blends creativity with programming, and it's a fantastic way to apply your skill if you love design and storytelling. And the sixth we have for cloud and DevOps. Maybe you are curious about how apps are deployed, scaled, and kept online around the world. Cloud engineering and DevOps is the backbone for modern software. In cloud, you can learn about AWS, Azure, or even Google Cloud, and you can exploit tools like Docker and Kubernetes. Now, cloud engineering ensures that apps don't just work on a laptop; they work for millions of users at once. Now, here is the important part. You don't need to master all of these. In fact, trying to learn everything will just slow you down. Pick one niche here that excites you and start building personal projects in that area. Now, because at the end of the day, what makes you grow is not just theory, but what you create. The sooner you choose a niche, the sooner you can focus, build projects, and position yourself for the career you want. Yeah, so this wraps up the video. We have walked through how I start learning programming if I was to start all over again, from building strong foundation with data structures and algorithm, to diving into C for the core concepts, and then choosing a niche like front end, back end, mobile, cloud, or even game development. At the end of the day, remember this: learning to code isn't just about theory, it's about building. The more projects you create, the faster you grow as a software engineer. Anyway, so thanks for watching, and I'll catch you guys in the next one. Peace.